Anyone who, watches the evening news knows exactly what a flash flood looks like.
Oh, yeah.
I mean, you see the footage all the time. It's usually like a 2-lane road down in some valley floor, and suddenly it's just overwhelmed by this wall of brown, churning water.
Right, it's terrifying.
It really is. Vehicles get swept sideways like toys,
Mhm.
and the hydraulic force involved in, even just 2 feet of moving water is staggering.
Yeah, it completely defies our modern engineered sense of like environmental control.
Exactly.
It forces this very sudden, very violent recalibration of how vulnerable we actually are. I mean, the hydrology of a sudden inundation, it doesn't care about your elevated highways or, your Doppler radar.
No, it really doesn't.
The sheer velocity of the water just erases the predictability of the landscape in minutes.
And when you look at the mortality statistics from the National Weather Service, flooding consistently kills more people in a typical year in the U.S. than tornadoes or hurricanes or lightning.
Which surprises a lot of people, I think.
It does, because the leading cause is usually just water crossing a road faster than a driver anticipated. So I want you to imagine something. Imagine you are standing in a river valley, maybe 1,000, maybe 3,000 years ago.
Okay.
You don't have a meteorological safety net. There's no weather app. You rely entirely on your ability to read the sky, the barometric shifts, the specific smell of the air, the churn and color of the river itself.
Right.
And because you carry the generational knowledge of your elders, a catastrophic once-in-a-century flood is coming. Not just a seasonal overflow, but a total geographical rewrite of the valley. So how do you save your people?
I mean, that is the defining human question of that environment right there.
Yeah.
Because when the geography you depend on turns suddenly lethal, your adaptations, they have to be structural. They have to be societal and just deeply, deeply resilient.
Which brings us to the core mission of our deep dive today. We are examining the immense 5,000-year architectural and societal history of the mound builders of the Mississippi drainage and the American Southeast.
It's such a massive topic.
It is, and we have a dense stack of sources today. We're looking at archaeological research, paleoclimatological data, geotechnical analysis, all detailing how these civilizations achieved something monumental.
Right. We're looking specifically at the massive earthen platform mounds, which are, some of the largest hand-built earthworks on the planet, but we're looking at them through a very distinct functional lens.
Yeah, let's lay out the rules of engagement here, so to speak.
Yeah.
Mainstream archaeology looks at these massive earthen mounds and sees temples and elite residences and tombs for chiefs.
And they are entirely right to do so. I mean, the stratigraphy and the artifactual evidence support that completely.
100%. We aren't here to dispute the sacred or political nature of these spaces, but today, in this deep dive, we are exploring a fascinating alternative version using our historical and environmental sources. We're asking, could a monument and a lifeboat be the exact same thing?
Yeah, we're evaluating whether the literal flood survival utility of these earthworks has been systematically undersold.
Okay, let's unpack this. Because to understand the architectural solution, we first need to thoroughly analyze the environmental battleground.
Right, the antagonist and the benefactor, basically.
Exactly. The Mississippi, the Ohio, the Illinois, the Black Warrior Rivers, these are the arteries of the continent. But they present a huge paradox for the people living alongside them.
Yeah, the floodplain paradox. And it's driven entirely by alluvial geomorphology.
Which means what exactly for our listeners?
Basically, it means these river bottoms are the absolute best agricultural real estate in North America.
Okay.
Because every time the river overtops its banks, the water spreads out and it slows down, it loses the kinetic energy it needs to carry all that suspended dirt and mud.
So it just drops it.
Exactly. As the water recedes, it leaves behind a fresh layer of nutrient-dense alluvial silt. It's incredibly rich in nitrogen, phosphorus, organic matter.
Free fertilizer.
Every single year. So for an agricultural society, settling on that floodplain is just a totally obvious economic calculation.
I mean, the caloric return on investment has to be staggering.
Oh, it is. That renewed soil supports intensive cultivation of maize-yine, which allows for population densities that simply are not sustainable on the upland soils. You see these complex, densely packed urban centers rise up purely because the carrying capacity of that alluvial dirt is so incredibly high.
But, and here's the cruel trap, the mechanism that delivers those nutrients is the exact same mechanism that can drown the field.
Precisely. The river deposits the soil, sure, But in an anomalous weather year, that same hydrological system will rise higher, move faster, and just scour the entire floodplain clean.
And this requires us to draw a really sharp distinction regarding agricultural loss. We have to separate the concept of losing a seasonal harvest from the catastrophic loss of a seed stock.
Yes, this is crucial. The biological and economic difference between those two things is the absolute crux of the floodplain survival problem.
Let's break that down.
So, losing the harvest.
Yeah.
If a late-season flood comes through, inundates the fields, and ruins the current year's crop, that is a tragedy. It induces a severe caloric deficit.
Right.
The community is going to face rationing, they'll have to rely heavily on wild forage, and they will suffer through a hungry winter. The demographic bottleneck.
Right.
But the society, structurally, will survive.
Because they still retain the mechanism for future production.
Exactly.
It's kind of like a modern financial disaster,
Right.
Losing a harvest is like losing your wallet. I mean, it's super painful, and you're going to have a bad month, but you can recover.
That's a good way to put it.
But losing the seed stock, that is like having your entire identity and all your bank accounts permanently erased. You cannot rebuild from that.
You really can't. Because in this ancient context, the seed stock is the machinery. This is the maize that has been meticulously selected for specific genetic traits like drought resistance, kernel size, stalk strength.
Right.
And it's set aside specifically to plant the following spring. It is literally the genetic repository of the civilization.
Wow.
So if the floodwaters reach that seed repository, the community faces an existential collapse. Even if the sun comes out the next day and leaves a pristine layer of fertile silt, it doesn't matter. They have absolutely nothing to put in the ground.
It's a definitive death sentence.
It is.
So the architectural challenge on a flat floodplain isn't just about sheltering human bodies for one bad night. I mean, humans are mobile.
Right. They can evacuate to the bluffs, or they can use canoes.
But surviving a river valley means keeping the society's engines safe for the year after the flood. The actual structural problem is engineering a dry, secure, immovable vault for the seeds.
Exactly. The vulnerability of a 50-pound basket of seed corn during a sudden flood is absolute. It can't run away. Therefore, the society has to permanently elevate the storage mechanism above the maximum historical flood stage.
And if the floodplain offers no natural high ground, the only solution is to build your own.
Which requires an almost unfathomable level of human physical endurance.
Let's talk about that. Let's talk about moving mountains by hand, because the sheer scale of earth moving here is staggering.
It really is, and to grasp the magnitude, you have to look at the numbers.
Which are huge, but we also have to be honest that no one has a firm count, right? Because of centuries of plowing and looting and just modern city building erasing the landscape.
Yeah, unfortunately.
Yeah.
But even with all that destruction, the estimates are wild. The USDA's Natural Resources Conservation Service has mapped roughly 1,100 mound sites in the state of Mississippi alone.
Just in Mississippi.
Right, out of like 26,000 archaeological sites there. And estimates suggest there were tens of thousands of these structures across the eastern seaboard and the Midwest.
And let's emphasize what these ancient builders did not have.
Oh, this is the most important part. There were absolutely no wheels, there were no carts, there were no draft animals like oxen or horses.
But no metal shovels.
No metallurgy for heavy excavation at all. Every single mountain of earth we are discussing today was excavated, transported, and compacted using human labor. And woven baskets.
And let that sink in. Every basket carried on a human back.
And each basket weighed roughly 50 to 60 pounds.
Okay, let's anchor this with some math. Let's look at Monk's Mound at Cahokia.
The biggest one.
Yeah. It contains roughly 22 million cubic feet of engineered earth. So pause and just do the math on that. Divide 22 million cubic feet by 50-pound basket loads.
You're talking about hundreds of millions of individual trips from the borrow pits to the construction site.
How does a society without beasts of burden socially and logistically organize that sheer volume of backbreaking labor? I mean, how do you even feed a workforce that size?
It implies a vast, highly efficient supply chain. The agricultural surplus needed just to subsidize the caloric expenditure of the construction teams means you have a deeply centralized political authority. And from an engineering standpoint, they weren't just piling up dirt. The basket loading technique is a highly sophisticated soil engineering method.
Really? How so?
Well, when archaeologists do stratigraphic cross-sections of these mounds, they don't just see a homogeneous pile of mud. They see these distinct lens-shaped deposits. You can actually
Yeah.
see the individual basket loads in the soil profile,
That is wild.
and you can see deliberate material selection. They were alternating loads of clay, sand, and loamy topsoil
Why do that?
for structural integrity.
Hmm.
If you build a mound entirely out of sand, it's just going to slump and wash away in the rain.
Hmm.
If you build it entirely out of clay, it suffers from internal hydrostatic pressure. It holds water, gets heavy, and eventually suffers a shear failure. It literally slides apart.
Oh, wow.
So by alternating the soil types, basket by basket, they created a composite material with internal drainage, capillary barriers, and incredibly high shear strength.
They were engineering the soil mechanics so their artificial mountain wouldn't wash away in the exact floods they were trying to survive.
Exactly. And they'd finish it with these thick clay caps. They'd cover the exterior with highly compacted, impermeable clay to shed rainwater laterally so it wouldn't infiltrate the core.
So to understand the societal organization that allowed millions of cubic feet of dirt to be moved and engineered by hand, we first have to strip away a massive historical lie.
Yes.
Because when 19th century white settlers encountered these massive earthworks, they basically couldn't fathom that indigenous populations built them.
Right. Their own biases wouldn't allow them to accept that Native Americans organized this incredible labor and engineering. So they invented a convenient, heavily racist fiction.
The lost race myth.
Yeah. Early antiquarians looked at the geotechnical sophistication, the clay caps, the volume, and they just completely decoupled the architecture from the living Native Americans they were actively displacing at the time.
They fabricated this story about a vanished civilization, like wandering Israelites or Vikings or some lost European society who built the mounds before being supposedly wiped out by native populations.
It was weaponized archaeology.
Yeah.
It was a narrative explicitly designed to sever indigenous peoples from their own heritage.
Because if the native people didn't build them, it provided a sort of twisted moral justification for manifest destiny.
Exactly. But it was definitively debunked in 1894.
Talk about that. How was it debunked?
Cyrus Thomas, who directed the Smithsonian's Bureau of Ethnology, executed this incredibly rigorous archaeological survey.
Right.
And he applied extensive stratigraphic analysis and comparative ethnography. He and his team demonstrated absolute continuity.
Meaning what, exactly?
Meaning the construction techniques, the artifacts found inside the mounds, like the pottery styles, the lithic technology, the copperwork, were directly, undeniably linked to the material culture of historical Native American tribes.
The proof was right there in the dirt.
Yes. Plus, they documented instances where early European explorers literally observed Native communities utilizing and building these structures. The evidence was overwhelming.
So we need to make sure we explicitly name who this history belongs to. The builders were not a single people, but dozens of distinct cultures over millennia. And they are directly ancestral to living native nations today.
Yes.
People like the Muskogee or Creek, the Ho-Chunk, the Osage, the Natchez, the Choctaw, and many others. This is a continuous, deeply rooted indigenous legacy.
And acknowledging that engineering genius forces a complete reevaluation of pre-colonial American history. Knowledge is only valuable when it's rooted in truth.
Absolutely. So, knowing that, let's trace how this astonishing dirt engineering evolved across an unbelievable 5,000-year timeline.
It's a massive span of time.
Let's start in the archaic root, roughly 4,000 to 3,500 BCE, which, just to put that in perspective, starts longer ago than the gap between us and the construction of the Egyptian pyramids.
It's mind-blowing. And the oldest known man complex is Watson Brake in Louisiana.
And what's so wild about Watson Brake is who built it.
Right. It was built by hunter-gatherers.
Which totally upends the traditional textbook model, right?
Completely. Conventional anthropological theory usually dictates that complex monumental architecture is a byproduct of agricultural surplus. You farm, you settle down, your population grows, and then you build.
But Watson Brake proves that the concept of engineered high ground on the floodplain is actually older than agriculture itself.
Yes. They were executing complex geotechnical engineering purely on the caloric surplus of wild game, fish, and foraging.
And that trend continues with Poverty Point, right?
Oh.
Also in Louisiana, built around 1700 to 1100 BCE.
Right, another pre-agricultural society. Poverty Point's incredible. It's a UNESCO World Heritage Site now. It has 6 concentric earthen ridges forming a semi-octagon 3/4 of a mile across, along with a 72-foot mound.
Built without farming.
There's vast trade networks and incredibly organized labor.
Okay, so moving forward into the woodland period, roughly 500 BCE to 500 CE, we see the Adena and Hopewell traditions. And here is where we need to be scrupulously honest with our sources.
Yes, we have to look at the data objectively.
The archaeological consensus is very clear that these specific woodland mounds do not support the lifeboat thesis. Not all mounds were for flood survival.
Right. The earthworks from this era were overwhelmingly ceremonial, astronomical, and mortuary. You see these massive conical burial mounds containing incredibly elaborate grave goods.
Stuff brought in from all over the continent.
Yeah, copper from the Great Lakes, marine shells from the Gulf of Mexico. And they also built staggering geometric enclosures, huge earthen octagons, circles, squares.
And they encoded precise astronomical alignments in them, too.
Very precise, tracking solar solstices and even the highly complex 18.6-year lunar standstill cycle. So the focus here is honoring the dead and mapping the cosmos, not necessarily securing a caloric base against water.
But the geotechnical expertise they refined over that 1,000 years mastering the soil mechanics we talked about, that becomes the foundation for the massive shift that happens around 900 CE.
The Mississippian climax.
Yes. What changes here?
Well, the inflection point is botanical. The widespread adoption of intensive maize agriculture takes hold.
Corn.
Right. Corn provides a reliable, storable surplus. And that surplus triggers a massive population boom. You see the emergence of sprawling, densely populated urban centers, places like Cahokia in Illinois, Moundville in Alabama, Etowah in Georgia.
And the architecture itself undergoes a radical transformation.
Exactly. The conical mortuary mounds are largely replaced by immense, flat-topped platform mounds. You see vast leveled public plazas, bastion defensive palisades, and most importantly for our deep dive, the widespread implementation of dedicated granaries.
Let's talk about the granaries, because we actually have historical corroboration for this. During Hernando de Soto's expedition through the southeast in the 1540s, his chronicler specifically described these towns keeping substantial amounts of stored maize.
Yes, and they weren't just digging pits in the ground.
Because subterranean storage on a floodplain is a terrible idea.
It's a recipe for catastrophic crop rot. The water table is way too high. So the Mississippians engineered elevated cribs.
How were they built?
They utilized wattle and daub construction. So woven river cane or branches, heavily plastered with clay, and raised up on sturdy cypress posts.
So the elevation gets it away from the ground moisture and the rodents.
Right. But it also facilitates critical airflow. Seed maize has to be kept at a moisture content below roughly 12 to 14%.
Or else what happens?
If it gets damper than that, you get a massive proliferation of aflatoxins and fungal decay. The seed dies. So the daubing helps regulate internal temperature and humidity. It's highly specialized architecture dedicated entirely to protecting the society's caloric engine.
Okay, so it is right here, surrounded by these vast maize surpluses, that the intersection of sacred monuments and literal survival comes into sharpest focus. This is where we get into the lifeboat hypothesis.
Yes. Temples, tombs, and safe deposit boxes.
Let's steelman the mainstream argument first. Let's lay out the strongest arguments against the lifeboat theory.
Sure. So excavations consistently show post holes of temples and elite residences right on the summits of these platform mounds. We know they were religious and political centers.
Right. And as we mentioned, earlier mounds clearly encode astronomical data, not flood data. Plus, moats at places like Etowah are very clearly defensive fortifications built against human enemies, not water management systems. And then there is the spatial objection. Let me play devil's advocate for a second.
Go for it.
The summits of these mounds are small, often just half an acre to an acre. If you have a city like Cahokia with 10 to 20,000 people, you cannot evacuate a city of 20,000 people onto a space the size of a few house lots. It just doesn't work. Plus, many of these mounds are already built on high natural levees anyway.
It's a very logical objection. If you assume the lifeboat is meant to be an ark for every single body in the town.
Right.
But our ReThink analysis answers this by returning to the seed stock. The lifeboat wasn't for the people.
It was a life raft for the society's engine.
Exactly. Because think about the hydrology of a flood. The water rises rapidly, yes, but rarely so instantaneously that a population familiar with the river can't mobilize. The people have canoes. They can temporarily migrate to the upland bluff.
They possess mobility?
The humans can move. But thousands of bushels of seed corn cannot. You can't frantically load all your seed maize into canoes in the middle of a torrential downpour without getting it wet.
And if it gets wet, it rots.
Right. The feed has to remain dry, secure, and stationary.
Here's where it gets really interesting to me. Let's look at how they balance the religious purpose with the literal crop protection.
Okay.
A platform mound perfectly elevates a chief, right? It
Hmm.
creates this massive theatrical stage that separates them from the ordinary world down in the plaza. It's a display of divine authority.
Yes. The chief is often viewed as having a direct lineage to the sun or celestial deities,
But why does that matter in the context of the harvest?
because that exact same engineered hill, the one holding the temple and the chief, is also what's keeping the community's seed corn completely dry.
Ah,
The religious and political power of the chief is intrinsically tethered to their ability to protect the future of the food supply. You'll often find granaries located in very close proximity to elite residences, sometimes directly on the mound complexes.
so a monument to the gods and a safe deposit box for the corn exist in the exact same pile of earth. The physical survival of the crops and the spiritual cohesion of the people rely on the same dirt.
Yes, but we have to encourage some critical thinking here. This raises a very difficult open question.
Which is?
Are we just looking at a happy coincidence?
What do you mean?
Well, water sheds off any large hill. If you build a 50-foot mound just to look closer to the sun gods, the top of it is going to stay dry naturally. How do we separate deliberate functional flood refuge design from an incidental benefit of building high?
That is tough. Proving intent in archaeology without written records is notoriously hard. But we do have a massive clue, something that acts almost like a historical ledger.
The environment's ledger, the mud cores.
Yes,
Yeah.
this is my favorite part of the research. Let's talk about the lull in the floods.
So paleoclimatologists have found this incredible anomaly. Between roughly 600 and 1200 CE, there was a multi-century lull in the biggest, most violent Mississippi River floods.
The river just quieted down.
It did. And because it was suddenly safer, people moved out onto the floodplain in massive numbers. Populations swelled. Farming intensified. And this is the exact window when Cahokia, the largest ancient city north of Mexico, rises to absolute power.
But how do we know the river was quiet?
Well, let's look at the study published by Samuel Munoz and his team in 2015.
The Horseshoe Lake study.
Right. So scientists took sediment cores from the bottom of an oxbow lake situated right next to the massive complex at Cahokia.
And for anyone who doesn't know, lacustrine coring, taking a tube of mud from a lake bottom, is like reading tree rings, right?
Exactly like that. Because it's an oxbow lake next to the river channel, during quiet years, it just slowly accumulates this very fine, dark organic sediment. Dead leaves, algae, slow runoff.
Right.
But when a catastrophic flood happens, the river overtops its banks with immense power, and it violently washes coarse sand and heavy light-colored silt directly into the lake.
So when you pull up a core sample, you're literally looking at a barcode of history.
Yes. The dark organic mud is interrupted by these distinct, thick bands of coarse sand. Every sand band is a massive flood. And by radiocarbon dating the organic bits trapped right above and below those bands.
You can date the floods perfectly.
Exactly. And the rise and fall in the mud is stunning. The core shows that the Great Flood stopped almost exactly in step with Cahokia's rise. The people took advantage of the quiet river to build a massive surplus and construct Monk's Mound.
But the mud also records the fall.
It does. Around 1200 CE onward, the stratigraphy changes again. The climate shifted. The massive bands of sand returned to the core. The catastrophic floods came back.
Now what happened to the city?
As the catastrophic floods returned, Cahokia began to unravel. If your chief's authority is based on protecting the harvest, and the river keeps washing the harvest away year after year, the political cohesion shatters.
The mound might keep the seed stock dry, but if you lose the crop in the field 5 years in a row, you starve anyway.
Right. The city was largely empty by roughly 1400 CE.
Which connects right back to our opening thought experiment. These people built life rafts of earth for 5,000 years. They mastered soil mechanics. They moved millions of cubic feet of dirt by hand.
But eventually, the climate shifted, and the river rewrote the valley in a way that even millions of baskets of dirt couldn't hold back.
It's incredibly humbling. Let's briefly recap the journey we've taken today. We explored the deadly paradox of river silt, how it gives life and takes it away.
We defined that vital difference between losing a seasonal meal and losing the genetic seed stock.
We looked at the sheer physical willpower of building 22 million cubic feet of high ground, basket by 50-pound basket, and we analyzed the dual nature of these mounds as both sacred temples and highly functional agricultural arcs.
And we had to dismantle those racist 19th century myths to give credit exactly where it is due to the indigenous engineers of the continent.
So I want you to think about this. The next time you cross a major river valley, or you see an earthen hill sitting on a flat plain, look at the landscape differently. Think about the thousands of years of survival and the millions of hands that shaped it.
And I'll leave you with one final lingering question to ponder on your own.
Okay.
We saw how an entire civilization's survival depended on this delicate balance of architectural engineering and generational knowledge of the river's rhythm.
Right.
But what happens to a highly structured society when the climate suddenly shifts so drastically that the floods defy the memory of the elders? When the high ground you built is no longer high enough?
Right.
What does that mean for our own modern infrastructure today?
That is something to seriously think about. Thank you for joining us on this deep dive.